This video is for just finding the domain of these functions. I also picked one from that we have from MyMathLab that you'll be asked to do. And for this one, you're asked to find the domain and the range. So let's get started. We have a situation. This is a polynomial. Not that we've really talked about that, but for all polynomials where there's nothing in the denominator, there's no x in the denominator. That's very important. No x in the denominator for these. This domain is going to be all reals. Now, if you were just writing it, that's what you would write. But since we're talking about MyMathLab questions, we write this in interval notation as negative infinity to infinity, and you'll be able to, there's infinity on the type code on MyMathLab and things. But for all of these types, even if it's just a regular old line or whatever, the domain will always be all real numbers, negative infinity to infinity. Now, when x is in the denominator, there's a problem if whatever's the denominator is equal to 0. So I'm going to take this and I'm going to set this equal to 0. X plus 2 is 0. So the problem point is at -2. So, you know, if we were just to be writing this, we would say, okay, this is all reals, comma, x is not equal to -2. And this would be a fine way to write it. But in interval notation, we actually have to take into account just that number line that here we are. If you remember number lines, here's -2. This is going to be an open dot, and everything else is okay. All of this other is okay. So I think of it like this. So remember, here at -2, it's not going to be anything. It cannot be that, or we're going to have a 0 in the denominator. So the way we would write this would be negative infinity up to -2 with a parentheses. We're going to put this u without the bar, and we're going to have -2 to infinity. And this means that we're skipping -2, so that's very important. For this function, I'm going to set the denominator equal to 0. So that means I'm going to factor it. We get -2 minus 3. So x minus 2 is 0, and x is equal to 2. And this one will give us x minus 3 is equal to 0, so x is equal to 3. So for this one, 2 and 3 are the bad points. So again, if you were to put these on a number line, here's 2, here's 3. These locations are open no matter what. Everything else is going to be okay. So everything else is in here, and we have it like that. Okay, so we also have what's in the middle here. That would be okay. So what would my interval notation be? Well, it's going to be negative infinity up to -2 with parentheses. I'm going to union it with -2 to with +2. I'm going to have +2 up to 3 with parentheses, and then I'm going to have a 3 up to infinity. So the same pattern happens. Now, there is one other type of problem that when I was previewing the homework I've assigned, you'll have this. Like if you have g of x is equal to the square root of x minus 3 over x plus 2. There are a couple of things that you have to keep in mind. The top part here, we can't have any negatives inside there, so x minus 3 must be greater than 0. And then on the bottom, we know that x is equal to -2 is a bad point. So this cannot happen. So if I go to my number line and see what's going on, so here is -2, and here is, because this is going to end up being x is greater than 3. So we've got 3, so everything is greater than 3 here. Oh, this can be greater than or equal to. So this can be a closed dot and everything to the right of it. And then this lower part, I'll do it down here. This is going to be an open dot and everything else is okay except this point. So in this case, we have to take into account both of them. It's kind of like you would think of it as an intersection. So the only thing that's the same is going to be right here. Right here. So it's going to be everything to the right of that. So if I keep changing all my colors here, my domain for this would actually just be bracket 3 to infinity. So that one I think is a bit hard. Let's take a look at this domain and range here. The domain are the x values, so we're going to be starting at -10. We're going to go up to here at 2. It's an open dot, but it is picked back up down here, so 2 is fine. And then it just keeps going to the right. This is going to be -10 to infinity. Infinities always get the parentheses. Now, as far as the range go, the range are our y values. So I think about this, I've got my y going to be everything from 6, even though here is open, it's actually valid over here. So I'm going down my y. Okay, here I am at y is equal to 1, 2, 3. No, that's actually -4. So at -4. And so we've got a 6 and we've got a -4. Let me write those in a darker color. And then we've got this constant here at -9. So it's just like one little dot here at -9. So just a thing. So this is a bit unusual, and I put it on here because I find it intriguing. My inner math nerd's like, ooh, this is a great problem. So I apologize if it's a little overwhelming, but what we'll have here will be just that one point at -9. We're going to put it in curly braces. And then I'm going to join it with -4, and that is a closed dot, so I'm going to use a bracket, all the way up to 6, and I'm going to close that bracket. So that's how this would be. And I mean, this is a challenging one as well. So, but I hope this helps. Let me know when you have questions, okay?